Hi, everyone. It's Mrs. Warner again. I know you missed me. I'll be back soon. So here's what we've got next. Lesson 1.2, addition and subtraction of radicals. So now that we are like masters of simplifying radicals, hopefully, if not, I'll have to sort it out when I get back. But we are going to take and add and subtract them together. Okay, so the first case is the best case scenario. You're going to look at all the radicands. Remember, those are the numbers underneath the symbol. And if the numbers underneath the symbol are all the same, so in the first example, there's like radical 11, radical 11, radical 11, jackpot. Then all we have to simply do is take the coefficients that are in the front, like the 3 and the 6 and the -5, we're going to combine those together. So 3 plus 6 is 9, take away 5, which is 4, and then we tack radical 11 on the back, and that's our answer. Because they had the same radicand, all we really need to do is deal with the coefficients that are in front of the radical symbol, and we're good to go. So we add or subtract them depending on what the symbol is there. That's only if they share the same radicand. But the next example is naughty. We've got an 18, an 8, and a 24. Oh, shoot. They're not simplified either. So what we're going to have to do is break them down, just like we did in lesson 1.1, which we've all mastered, hopefully. So we're going to take -3, and then we're going to do square root of 9 and square root of 2 for the 18. Because remember, 18 is really 9 times 2. All right, that's going to simplify down even more to -3 times 3, radical 2. And -3 times 3 is now simply -9, radical 2. So the first part of that example that we're trying to solve is actually now simplified. Now we're going to move on to the next part. So it says +3, and this radical 8, I'm going to make radical 4 and radical 2. But now the square root of 4 is actually a 2. So it's 3 times 2, radical 2, or 6, radical 2. Well, that's awesome because in the front I have -9, radical 2, so eventually those are going to join together. But now I still have to do this radical 24. So that's going to be 4 and 6 because 4 is a perfect square. And the 4 can simplify down to now be -2, radical 6. All right, so I'm going to rewrite this up here. I have -9. Well, I'm going to write it down here. Just kidding. -9, radical 2 plus 6, radical 2 minus 2, radical 6. And what I'm going to do is I'm going to look for the ones that have the same radicand. They all have the same index. They're all square roots, so I'm good to go on that. -9 plus 6, because these guys can be combined together because they're both a radical 2. So -9 plus 6 is really -3, radical 2, and then this guy doesn't have a friend. That's so sad, but that's okay. I'm just going to tack him on the back, so -2, radical 6, and this is my final answer. I don't put them together. It looks kind of ugly, but they're not really friends, so they don't want to hang out. They don't have the same radicand, so you can't combine up their coefficients in front. That was fun. Let's do some more. I know you're so excited. Okay, so look, radical 12, radical 75, and 3, radical 3. Let's try to simplify. So radical 12 is really radical 4 times radical 3 because the square root of 4 is a 2. So now it's 2, radical 3. Radical 75 is really 25 times 3. So now that's 5, radical 3, plus this 3, radical 3 in the back. They're all radical 3. It's my absolute luckiest day ever. So now I'm going to take the 2, the 5, and the 3, and I'm going to add those together. So 2 plus 5 is 7, plus 3 is 10. So this final answer is 10 radical 3, because you just simply add the coefficients once they have the same radicand. Let's try it again. Oh, I'm getting good at this. Radical 12 is 4 times 3. And the square root of 4 is really 2 radical 3. But radical 27, we got to break that down. That's 9 times 3. So now that's 3 radical 3. And when you add those together, you get 5 radical 3. Wow, piece of cake. And just when you think it's easy, Mrs. Warner throws this crazy square root of 4 ninths. Whoa, people. There's a fraction under there. That's okay. Just take the square root of 4, which is how much? 2, and take the square root of 9. So I just simply broke that up into radical 4 over radical 9, and now it becomes 2/3. Not as bad as it looks. Break that division problem or fraction into 2 different radicals. I've got this minus radical 13, which I'm not going to simplify because it's the square root of 13, and that's a decimal if you type that in. And then I'm going to go back here, and I'm going to do 1/3. Now listen, I'm probably going to want to combine that up with this 13. So 1/17 is a big number. I'm going to take 1/17 on my calculator and divide it by 13. And I'm going to see that it goes in there 9 times. And I'm like, wow, because the 9 is a perfect square. So this is really radical 9 times radical 13. Wasn't that fun? So now I've got 2/3 minus radical 13 plus 1/3 times 3 radical 13. Oh my God, there's so much going on. So now I have 2/3 minus radical 13, but what's 1/3 of 3? 1. So now that's really a plus radical 13, and this problem just gets crazier because now this minus radical 13 and this plus radical 13 cancel each other out, so the whole answer to the problem is 2/3. Who made that problem up? I did, and it was super fun. So there's the 2 cases when you're adding or subtracting. If the radicals are all the same, that's what we did way up here at the top, where they were all square root of 11. Just take their coefficients and add them up. But if the radicands are not simplified, then you need to break them down and look for ones that are alike before you can add their coefficients. So your task now is to finish the 4 practice problems that are located there. You can do it, enter them in, and make sure that you get them correct. I'm so proud of you guys, and I can't wait to see you again. I'll be back. Bye, guys. Oh, shoot, I never know how to turn this off.